values represent? What is it? What do they represent? Again? A point. Follow the equal signs. And dy dx represents the slope of a line tangent to the original curve at the point. Well, we have the point square root of 5 and 4/3 and square root of 5 and negative 4/3. And so we have 2 points. Okay. Now, find two explicit functions equivalent to that original equation. Okay. I need a lot more room for this. So let's start another page. Okay, so this is going to use something that I know you learned back in probably Algebra 2. So we have 4x squared plus 9y squared equals 36. I want to find two explicit. Actually, we won't have to work quite as hard for this. I thought we'd have to complete the square, but we don't because of the nature of this. I want to know what y is equal to. So let's see. 9y squared, we can start with that. 36 minus 4x squared. And divide both sides by 9. So I have y squared equals. Some of you are tempted to say, ooh, I can cancel 9 into 36. I know you do because they had it on the test. Think about it. You can only cancel factors. Is 36 multiplied to everything in the numerator? Is it a factor? Okay, we're getting a no on that. So can you cancel that? No, we can't do anything with that. Okay, so now we have that y equals plus or minus the square root of 36 minus 4x squared divided by 9. Now, can we simplify that? How? Okay, square root of 9 would be 3. What about the square root of 36 minus 4x squared? Factors, right? Factor out of 4 of the numerator. And so I heard some mumbling, but I'm not sure what that was. Did you say 2, the square root of 9 minus x squared? Okay. Some of you are looking at me like, what on earth was she doing? Well, I'm just following through with some algebra here. One is writing it as y equals plus or minus by, again, dividing by 9. But then if I look at the square root of that, you're allowed to break up the exponents on the numerator and denominator. So I'd have the square root of the numerator divided by the square root of the denominator. Square root of the denominator would be 9. Square root of 9 is 3. Numerator, I can factor out of 4. Take that square root, I'd have 2, and then that factor. So now let's take the inspires. Let's see what we can do here. Go ahead and add another graph page. I guess we didn't do anything on F1 yet, but let's see what we have here. I'm going to have to put in F1 of x and use 2 square root 9 minus x squared, divide by 3, and then use F2 of x and make it negative 2 square root 9 minus x squared, divide by 3. Okay, so there's the first half of that. I'm going to move that label up so it's out of the way. Press tab to get the entry line back. Now we could type that in again, but I'm a little bit of a lazy mathematician, and I'd rather not type it again. And so instead of typing it again, what could I do? How does F2 and F compare to F1? So I can just say negative. So the change of sign of F1 of X. You can type it again if you wish. There's nothing wrong with that. But F2 is the opposite sign of F1. And if I do that, it should be exactly the same, except that all my outputs are now negative, and I get that piece then down here. Now, back on our work, what did we say we came up with? What do these represent? Slopes of lines tangent to the original graph. Okay. At what point? At the square root of 5. Okay. So now we're going to go in here, and you've done this before. Let's do the routine of putting points on here. So I'll put a point on the first one and a point on F2. The input has to be what? Square root of 5. So I'm not going to try and put a decimal there. I'm going to put in the square root of 5. It will change it to a decimal. And I'll do the same thing down here. Actually, I don't want negative square root of 5, do I? I just want the square root of 5. Yeah. If we had made a mistake on that, could we have corrected it? Sure. Just go in and retype that number. So I have 2 points. How do the outputs vary with those, with that input? Consistent? Yeah, absolutely consistent. Okay, go ahead. You know that what we need to do is put a tangent at each of those. What am I wanting to accomplish with this? What am I trying to find out? Slopes, okay. You know, these are all, you know, the usual. We're doing the same thing over and over again. We're looking at the slopes of the tangents. How do I know that this decimal is equivalent to what my answer is? I sure didn't get this decimal, did you? In my analytical work? Because I got negative 5 the square root of 3 and square root of 5. I'm sorry, negative the square root of 5 divided by 3 and the square root of 5 divided by 3. So what do I need to do to verify that those are in fact correct? Take care of it. Does it come out to be about that? Okay. Close enough that we know that our work is correct? Whoops. Is that the same thing? Yes, it is. Okay. So let's go back and look at this. We found the slopes on this page by doing it analytically. We didn't get the decimal part of it, but we did have our values here. We then looked at the, using the explicit, divided it up into 2 functions. We can graph those 2 functions. And we know that, that those are equivalent. What is it, 0.745?
Yes.
Actually, if I use a the top one up there, 0.745 and negative 0.745. There we go. Okay. It is consistent. So I can do it either way. Either way I wanted to do it. I can either do it explicitly or implicitly. Now, the third part of this was said to sketch the graphs. We did. Differentiate the, we didn't differentiate, did we, the explicit? Okay. All we did was find those equations, so let's go through and do that piece of it. So if I differentiate this, these explicit, what am I going to get? The same thing I got before? I don't know. Let's see what happens. Okay, so I want to do the derivative. The derivative of, I'm going to make this 2/3, 9 minus x squared to the 1/2 power. Pulling out the 2 divided by 3 is 2/3. If I look at the derivative of that, I'm going to have my coefficient times my exponent. Again, I'm doing the outside function here and subtracting 1. So I'm just looking at the outside function now as something to the 1/2. And then I must take the derivative with respect to x of 9 minus x squared. If you take a look at this, 2/3 times 1/2 looks like 1/3 to me. How about to you? Some of my students in the other classes missed some points on the test because I know I've said this more than once. Please write all of the answers with positive exponents only. So that would be written like that. And then my derivative of 9 minus x squared. How about negative 2x? Okay. The variable of differentiation matches this, so we're just fine. And so I have negative 2x divided by 3, the quantity 9 minus x squared to the 1/2 power. At what point? Remember it on the first page? We wanted to evaluate this at an input of how much? So at x equals square root of 5, f1, derivative of f1 of x would be negative 2 square root 5 divided by 3 times the square root of 9 minus square root 5 quantity squared. Am I going to get the same answer? Square root of 9 minus 5, the square root of 4. That'd be 2. How am I doing? Are we getting the same answer? Yeah. Exact same. Do I need to go through the other piece to prove that we get the same answer on that one too? The other one said plus or minus. This is just giving us the negative part of it. Now, remember, you need to go back and redo these problems on your own, not